All right. I have just a little bit after, and while people are still joining, I want to get started because we have a lot of really interesting stuff to talk about here today. So, welcome to today's Globe Observer Connect. As a reminder, we are recording this, so if you do not want to be on screen or have your voice in the recording, please use the chat to ask questions or to make comments. Um, but otherwise, you're welcome to raise your hand or speak up. It's a conversation, and we look forward to talking to you. So I'm Holly Cole. I coordinate the Globe Observer um, project, and it's really great to be here today. Give me half a second. I need to share my screen. Um, there we go. So today's Globe Observer Connect is about artificial intelligence and Globe. Um, and it's based on a paper that was published at the end of last year. The paper looked at a few different ways different people have been using artificial intelligence, particularly image recognition, to analyze Globe data and even to implement Globe. And so we're here to share some of that paper, but if you're interested, there is a summary of it on the Globe Observer website under the news section. And also, you can go find there a link to the paper itself. So if you want to read more, it's all there. Um, I'm only going to spend a couple minutes, but in terms of using artificial intelligence, the Globe program has integrated uh, image recognition into the Globe Observer app and the Globe data system. And the reason for that is when you submit photos as part of taking data through Globe Observer, we had been manually screening all of the photos. They go into a public database that are meant for kids to look at, and we wanted to make sure that there was nothing inappropriate in that database that a child could come across. And also, we wanted to protect people's privacy, particularly children who were collecting data. And so before, we would screen all the photos, and anything that had a person in it where you could recognize a face or text, we didn't accept that data at all, and those photos would be discarded. But a couple of years ago, we started using Amazon Recognition to screen the photos, and that had the advantage of the photos go through and into the database much more quickly. So you see your photos there after 15 minutes or so, whereas before it might be a day or two before one of us finally got around to looking at your pictures. So it goes in much more quickly, but also we're able to accept all the photos because we're able to blur out faces so that this is a child who took a picture as part of their observation, included themselves in the picture, and so we're able to blur out that face and accept the data, but without compromising that person's privacy. We also blur out text, so the car license plates in this second photo here are blurred. And so all of that is to protect privacy. So it's integrated, AI is integrated into Globe in a way. But I am really excited to hear from some of the scientists who are working on using artificial intelligence image recognition to analyze the data and to create science. So I'm going to pass this over to Dr. Dee Yang, who's going to talk to us about some of her current work. And then we'll have Dr. Rusty Lowe and Peter Nelson present some of the other things that are in that paper. So I'm going to stop sharing and hand it over to you now.
But Dee, let's start off with this paper that we wrote, right? Where we really highlighted this idea of using AI front and center in the work that we are doing, right? And in our paper, we have kind of this a workflow that we put together, right? And you've been working with Globe Observer data now for 5 years, right?
Yeah.
Since we really were able to first experiment around with this idea of computer AI frameworks. So, from your experience, give us a little definition of what AI is to begin with.
Oh my goodness. Yeah, that's so right. Like AI is kind of like that's a great question. And in the like the geospatial analysis world from geography point of view, like AI basically is everything. So yeah, so the AI means that in our study that we are kind of for a lot of the definition in classifying or land cover or mosquito habitat mappers, so the AI will be able to trying to distinguish the patterns or classify the different type of the classes based on the more intelligent way other than like the traditional physical models. So that's yeah, that's how we define that. If that answers your question.
It does. And I think one of the things that's exciting is you as a geographer, I'm also a geographer. And
Oh,
so this way that we see the world is really related to latitude, longitude, and what we can find there. And in that way, remote sensing and computer geography has been happening and using these tools, these classification tools for since the beginning, really. And so I think one of the things that's exciting here is this new framework, right? With the cloud computing, this ability to use a lot of computation, right? And so thanks for that, Dee. And what I want to do is kind of highlight what we'll talk about today, which is, what happens after the Globe Observer goes out there and collects some data. And when I say data, I'm really actually talking about the spectral measurements that are coming in through the imagery, right? And this is something that is common across the clouds, the mosquito habitat mapper, land cover, and also trees. This is a common thing that we're actually using our mobile devices to capture is that sunlight. But then, as Holly was mentioning, it needs to go into a database so that it can be co-located with all of this NASA data created data, but also all the other data that is available to help us understand what we're seeing. Right. So I think one of the big things is, Dee, you and I really come in, and Rusty, you also come in kind of after this transfer of data from our devices up to Globe, as you discussed, Holly, right? Where you guys kind of do some things with it. And unfortunately, it does change things, right? If we go back to this, knowing that, oh, we actually can't run statistics across this whole thing because we have some changes in our values is something that ends up sort of affecting our process downstream. So this is just kind of one of these things that we're considering, when we're evaluating and looking at this data, which sort of led us to really you needing to help us step in and do this classification of these uploaded images, right? And to me, that was one of these really exciting pieces that you were part of that early group that experimented with this. And Rusty, you and I helped mentor about 4 different groups that were experimenting with ways of using classification, right, to identify those images.
These were all NASA projects.
Yeah, and so Dee, give us a little sense for what you really found out as you looked at the photos that came in. Not the idea of what we wanted to do, but you kind of got the reality of it, right? Of like, okay, if we get all this data, what do we find?
yeah, that's a great starting point. Thank you, Peter, for introducing. And so on the left corner that we can see that there is or all 4 different view directional photos of the Globe Observer land cover. And so as we know that the Observer land cover takes 6 different directional photos, and then we are using the 4 directional north, south, west, and east. So here they are performing a perfect 360-degree point of view. So that like unique standardized protocol really bring the Global Observer land cover an amazing place. So we want to test out like how to actually merge those imagery to map the land cover classes more accurate, like with a more higher accuracy. So we developed different type of data fusion methodology as well to kind of reach out, oh, how much better actually can we reach out to the point that we can reach to like how much better behavior the classes are if we have all the 4 different directional view. And the other part of the AI point that I want to bring out here is that the Global Observer land cover really is the perfect place for applying AI because as we know, a lot of deep learning methodology, we need a gigantic number of training samples. And that brings up that like that's perfect matching the numbers of the citizen science global observer database. So that we can really like trying to apply the deep learning methodology in those geospatial analysis. So, and the results that we're turning out is very exciting because we are getting the results say the more views actually we can get much higher land cover classification and with one of the examples that we can see here is with all 4 different directional view, and then it's like around 15% higher than a single view. So that can lead like a very great level of the accuracy jumping from the geographer perspective. And also like this is also important for the protocol itself because that means that the level of the information that you fill into the observation that can also like make a huge difference in the final mapping land cover classes result.
Yeah, Dee, I really love this because really what you're highlighting is one photo is useful, but
Mm-hmm.
4 photos are really, really useful. And importantly, if people labeled each one of those directions, like we encourage them to do with their fractional cover, when we have this variety in a location, it really helps us to describe that a lot better than just one photo, right? And that's
Yeah.
one of the things I really love about this graphic that you highlighted for us is we're doing something really good
Yeah,
by
thank
doing
you.
these different directions.
Yeah, I will just have one more sentence to add.
Yeah.
So in a lot of the pairs that the 4 directional view that we might have the classes like for example, 3 pictures they are classified as forest and one the other as the other land cover classes. So even those we are also showing the increasing mapping accuracy as well. So that is a very important outcome for the multiple view the protocol.
Yeah. And that is really exciting. And part of, what you did is really show us the value of what we're doing and thinking about how we arrange these images, which I really like is like, do we just stack them together or do we sort of label them in different ways? Like this whole thing of how we put together all of these directions as input is actually a space that I've been kind of like playing around with is like it's a lot of fun to twist these photos around and see how they
Mhm.
actually work together. And I think I want to highlight one of our other groups from University of Vermont that they specifically at the time were working with Amazon's web services and their SageMaker, kind of that next piece out of once we blur or Holly in your group, you blur the photos. Well, if we can keep it in that same Amazon space, what do we end up finding out? And can we use just some of their pieces? So they did some experiments around, and one of the things that I thought was really an interesting take home is we don't need to get all detailed with some of these things. And Dee, you kind of highlighted that too. In fact, sort of the general aspect and the colors and the shapes are actually doing a really good job of helping us identify the objects inside of there. So even though a lot of us want to go to, hey, can we find those cars inside of there? And some of those things. In terms of cost benefit with computers and time and some of those things, some of these other methods that we've been using for 10 years, 20 years can actually still do a really good job. And so again, as we think about our labeling, one of the things that is really, really important is we need reference data. How do we know that we're actually finding the right things in these images? And this is where it's really important for people to label what they're finding in those photos. Otherwise, we sort of have to spend a lot of time on the computer trying to identify herbaceous or open water or some of those kind of classes. So unfortunately, our data set goes down to 30% of our photos are getting labeled right now. And so that actually makes this process that Dee was going through very, very important, because what do we know is in these photos unless we do some of this AI work? So I just kind of want to highlight how exciting it is that we've had a lot of people who've been leading us in this way. And before we really open it up for conversation, I want to show where we're going with this and how not only are we trying to label our photos, but importantly, NASA, along with the whole remote sensing community that's mapping Earth from space, they're creating their own maps out there. And so these are AI processes, if you will, but they're making classifications and predictions about your location. And so this is the other part of the AI piece, is that we are now getting a lot of predictions of places. And Dee, you can back me up. I mean, we've got a lot of land cover maps that are coming out at different resolutions. And so part of our job here actually is to provide the ground photos that help us evaluate whether all of these AI map models that are coming out from different groups are describing our location well. And what I want to highlight with this is this particular student did a study across New York City, and we were able to compare 3 different maps. One of them coming from Google, one of them coming from ESRI, and one of them coming from the European Union. And what I just want you to take home is that there's variation here that needs more investigation. So that's where I want to open it up and have you guys ask us some questions about what we're doing and maybe how you can be involved, or some ideas that you have for us about this AI work, because we're just experimenting around, and so is a lot of other people. So let's open it up now to some of those questions, Holly, that might have come up in the discussion. And Rusty, your finger's up. So
well, do I get to talk?
Yes, you can talk, Rusty.
Because I just wanted to we also wanted to talk a little bit about the mosquitoes. But Peter, thank you for saying let's look at the questions. There are like at least 3 questions. One I thought that Dee could answer about humans in the AI process. Another one about determining aspect on photos. And while we're talking, let me just quickly share my screen. Will you please?
Yes.
So. Thanks so much. And I'm really glad to be part of this incredible paper, I think, that we put together. It represents a lot of work that we've been working on, like Peter said, using that model of what our vision was a year or 2 after we started the Globe Observer program. Eventually, I think AI is going to really help us in all different areas. Today, I just want to finish up the discussion today talking about the application to mosquitoes. And in fact, the work that we've done with mosquitoes has really stimulated some of Dr. Yang's research in land cover as well. And she has now a mosquito and land cover proposal funded by NSF. So just want to let you know that this is where you guys stand, all citizen scientists. This is all of the ways that NASA observes the world around us. And Globe Observer are NASA's eyes and ears. on the ground. And so there we are right there, part of the important NASA mission. And I just wanted to clarify here that one of the points that was made is that in order to train an AI system so that it can recognize faces or license plates or different kinds of vegetation or mosquitoes, you need hundreds and thousands of photos because the more data that you have and the better data that you have to train the AI system to create the mathematical equations that it runs, the better it is. And this is why AI is a fantastic, I should say, citizen science is a fantastic partner for a lot of AI projects. So here are some of the beautiful mosquito photos that we have gotten from our citizen scientists around the world with Globe Observer. And I wanted to make a special call out today to Monsieur Paul Randrian Soa. I know him well, but his name is hard to say. Bonjour, Paul. Paul is at yeah, bonjour. Paul is at Madagascar, and it is his citizen science team that provided this data that started us on the way of using AI to recognize mosquitoes. And I can't tell the whole story. It's fantastic. What a great um, effort has been made in Madagascar with a Globe Observer mosquito habitat mapper. But the short story is they here in Madagascar, in the capital city, somebody found tires, and they sent images of the habitat, which is the tire, the water in the tire. They sent a picture of the mosquito, and then when we reviewed the data, we went, "Oh my gosh, this is not the kind of mosquito we expect to see in a container. This is the kind of mosquito that likes to live in floodwaters. It's a malaria mosquito, an Anopheles mosquito." And so we knew that there was a very, very dangerous new mosquito which has just come into Africa. First appearance was in 2012. It's now found in quite a few places in Ethiopia and also quite a few places on the west coast as well, but has never been seen in Madagascar. On the basis of the work that we did with the program with sponsored by the National Science Foundation in the US, we were able to develop a mosquito ID system looking at larvae, and we were able to determine that this mosquito was one of these dangerous invasive mosquitoes, alerting the citizen scientists in Madagascar that it's really important to continue their surveillance and continue their mitigation because this mosquito can change dangerous malaria, which is one of the biggest killers of humans in the world even today. Um, we don't want it to become an urban disease, which is if we have Anopheles mosquitoes that are finding their breeding sites in tires and containers, they move from rural areas to urban areas, and it suddenly becomes a huge problem. So once again, thank you very much, Paul, for all the work that was done in Madagascar, and thank you for coming to this session today. And so now you see, yeah, yeah. So now you can see that there are all different ways we're using artificial intelligence. We're using it in the screening the mosquitoes. We are using it to screen the faces and make sure that the data that gets into the database is accurate. And we are even doing it now in more complicated analyses using land cover. Thank you.
Thank you so much, Rusty and Peter and Dee. Excuse me. There's some really great questions in the chat. And I think I'd like to start with this one from the students in Virginia. They are asking if you think there will ever be a point where humans, I cannot speak, are no longer a part of the process. And when would that be?
Dee, that's a great question for you, I think. It's a hard one that, only students, I think, are the ones that are, well, not, but, these kinds of questions come from an authentic place that sometimes we don't think about. So, Dee, I don't know if this is something you've thought about, but you are the AI scientist here, so.
Yeah, so we use in a lot of cases, we use about, I think, like humans still play a very important critical role in the mapping processes because so if, for example, if we use like land cover, for example, we can map out like with 10 different machine learning algorithm with very high resolution, with very high accuracy. But the people who really like making the decision, so with the critical thinking ability, is still human. So we are gonna be having the power for like really like see, oh, if this map is representing the real world. And I think that will be still the case for a very long period of time. Um, yeah, Peter and Rusty, please help me.
Yeah, Dee, I think one of the things is humans are the ones that are asking the questions.
Yeah.
And we're the ones that are even designing these systems to give us maybe quicker feedback about soil moisture or what we might expect when we travel to a location, right? And that navigation question is humans. And we're trying to do something, right? And so, in essence, we're always going to be kind of in the middle there, always sort of trying to figure out how, like, what's around us in this world. And I want to highlight how we get this hypothesis from these satellites and from this digital twin that we're building up, and NASA's like really giving us this high resolution information. But the world is constantly changing. And so, what it was this year, we've had volcanoes, we've had earthquakes, we've had all kinds of things that actually are shifting and changing the shapes of the earth. So, in essence, our job is never really done in terms of really understanding these processes that might actually take 50 years of continual observations to really see in the data. And I think one of the things that becomes challenging is we have changing technology, and this AI piece is just another iteration of, oh my gosh, how can we process all of this information that we're collecting to try to answer some of these questions. But I'll go back that I've seen looking at the history of these and why do we have satellites in space? It's kind of the same questions as it was in 1970. What is where? And why are they there, right? And so this human piece, I think, is a really interesting part. And I want to just end my little piece here with saying these are all predictions, right? And so that's part of why this new phase is actually checking all of these maps, and they're really not certain. There is uncertainty with these predictions. And if you approach it as a prediction, then it really brings us back to the science enterprise. And I want to highlight how that is really a human endeavor, right? And this is where pay attention to the decimal points. We'll get more of those, but it still goes back to, are we talking about the same tree? Are we talking about the same location? And if so, what is happening to these places? So I think we've got a large future ahead of us. It's going to look different, though.
It is. Holly, I know we're at time. Can we answer one or two more questions?
Yeah, give me half a second here. So we are at time. If you need to go, I do understand, but I'm willing to stay on to answer a few more questions. But I do want to, before everybody takes off, let you know that our next Globe Observer Connect is on August 14th at 7 p.m. Eastern Time. And we will be talking to some of the cadets who are collecting data for scientists at NASA Langley Research Center about contrails. And they're going to share some of their experience, and then we're going to hear a little bit about some of the results coming out of that mission. So I'm super excited. It'll be a really fun one. Please watch the Globe Observer website for information about how to register. We'll be posting that here very soon. And save the date, August 14th. So thank you for coming. Again, I'm happy to stay here for a little while and keep talking. We had a lot of content today. But if not, if you need to leave, we'll hopefully see you next time. Thank you.
Thank you,
Rusty,
Holly.
go ahead.
I was just going to say there was a great question about weather. And what we call AI today is basically automated analysis, and this has been going on for years, long before AI became something that we talk about in social media. But yeah, weather prediction is completely revolutionized by the use of AI. We get faster, more accurate forecasting, and it's even allowing us now to do something we never thought possible, which is what they call nowcasting. So, like, you can say what's going to happen in the next few minutes or hours. And so this is something incredibly important. And what's really cool is that, we're certainly not integrated into that system right now through Globe Observer, but there's always the chance that as technology improves, both with our app and also making the connections, this data could be utilized in this kind of system. Another question that I thought was really, really important, one of the someone asked about the using what kind of AI system that we use and whether or not it's free. And Holly mentioned that for the Globe Observer using Amazon Rekognition, that is a paid for service. But Dee, there are a lot of platforms that are out there that you can use for learning and for research that do not cost. And Dee, can you address that a little bit?
Yeah, so um we use a lot of like Google Earth Engine. So for example, we use deep learning and AI. And but when it reaches to deep learning, we still need a lot of computing power. So and that is so in at UF we just run that on the HPC, the higher computer like professional machines. So yeah, that's what we use for AI purposes.
Okay, thank you. That's great. You also, yesterday, when you were talking to the STEM Enhancement Earth Science NASA interns, you talked about a Google tool that they can use to
Oh yeah.
mention that because there are some
Oh,
brilliant scientists on this call, young scientists that might want to use that.
yeah, so there is a great platform called Google Teachable Machines. So in that machines, you will be able to build your own AI models by just inputting or importing your photos. And so feel free to test it out, and it's completely free. Um, then they will the another high point, like the other capacity for them is very interesting is that they will like give you the script of your model, and then you can reuse it anywhere else later on, and in the Jupyter notebook, for example. Yeah.
Thank you so much. And I'm really hoping that some of the learners on this call might be interested in just exploring this. And the important thing is that all the Globe data is open and accessible, that we have collected also the Globe Observer data. You can download our images and do your own experiments. So thank you so much. And oh yeah, Peter, mention just briefly talk about the RSET training because that's something that everybody can also do for free, and it's a great NASA asset. Okay. So click in the chat if you want to learn more about the applied science training that they have, and it is really, really good. And there's one on fundamentals of learning earth science. So anybody who's not doesn't have access to university courses to do this, you can do a lot of self-study on your own and even become an expert with work. Okay, have we covered everything, Holly?
You've covered a lot. Cassie is just reminding me in the chat, for those of you who are interested, we are starting a new project or a new data request with a group that is using Globe Observer photos to monitor the impact of disasters in the southern United States as a pilot, but I think they're interested in doing this for a larger region. So there is a webinar about it on Monday at 1 p.m. Eastern Time. I don't know off the top of my head what that is in UTC. I again can't do math on the fly like this. So we would love to have you there. That information here. Let me put the URL for it so you can register if you would like to. I will put that in the chat. But that's another project that's using the photos and a bit of image recognition. They're going to be looking at how they can use those to integrate with satellite data and either create forecasting or understanding the data as it comes back, the satellite data as it comes back, and improving how they can monitor disasters. So it's related to the work we're talking about here. If you're interested, please join us on Monday. We'll record it. If you can't come on Monday, you can read about it on the website as well. And that URL I put there includes links to more information. So we'd love to have you join us. All right. I think that is
I have a few
all.
questions.
Yes, go ahead, Anto.
So, how exactly can AI improve our understanding of weather, and in what ways can AI process satellite or radar data differently than the past generations?
Oh, what a good question. And it's a very sophisticated question. And I think that I'm not a meteorologist, nor is Holly, nor is Peter or Dee. So I think we need to take this question to other specialists. But the bottom line is data, and data can be analyzed, through using a machine learning algorithms that look for patterns. And so, like you said, and very nicely, I think that, we are not talking about, AI came up 2 years ago and now we're applying it to weather. No, AI has played an important role. When I was a graduate student in 2001, we actually developed our own machine learning system to do some analyze data. We did it in an Excel spreadsheet. It was not fast. It was not, but what I want to say is that AI has played an important role in the Weather Service for a long time. And to better understand that, I think what you might want to do is go to Google Scholar and read about the history of weather prediction. And I think that you will find your answer there. And, you know, I'm a climate person. Peter is a land cover person. Dee is a geographer who is also works with land cover. Holly is also does a lot with land cover and many, many other things with clouds. But I think that would be your definitive source. And then I would also encourage you, if you read someone's paper and you really like the paper, every paper has an email that is associated with it, and you can reach out to that scientist and tell them who you are and tell them why you're interested. And I bet 9 times out of 10, you're going to get an answer from that scientist because scientists are always willing to share their knowledge and they are very interested. I know all of us scientists here can say this. All of us are very interested in supporting young people like yourself who are looking at careers. So
you can come to our next Globe Observer Connect, which will feature our clouds team, who are meteorologists, and ask your question then.
And ask the question again. That is yeah. I missed that, Holly. Thank you.
So I'll jump in and I'll say I'm a meteorologist, but it doesn't mean I have the answer. Rusty, that was a great answer. And you know as much as I do about the AI and forecasting.
Thank you, Kevin. It's nice to have you here, sir. Dr. Sikowski also works a lot with GLOBE. His team has worked a lot with Urban Heat Island and looking at surface temperature change over time. So there's a lot of expertise in this room, and I'm really honored to be a small part of it.
Okay, and I have one final question.
Oh.
So talking about data, how does AI help figure the types of weather according to geography and longitude and latitude?
I'll take this one. Lots of observations. And so we have satellites that have been focused on Earth for about 70 years. And so through all of those continuous measurements focused on one place, you can see how the weather moves through. And there's a great tool that NASA has called Worldview, that you can actually see the clouds moving over the world, all from that satellite perspective. And, many students have gone to school and that's what they study is one particular latitude, longitude, and look at that place over many, many satellite images. And from that, they're able to sort of figure out, it's always clear here. I can see, the ground. That's great for me as a land cover scientist. But if it's always cloudy there and it's always sort of white and bright, that might indicate something else that you might experience on the ground. So it's really those repeat measurements that we've been doing collectively for about 70 years that really help us to understand it from that different perspective than all of the ground measurements that people have been making for a really long time. So if you go look at NASA's worldview, you can actually start learning and seeing how the clouds move around. And it's only through that that we really can understand at a specific location, it's going to be cloud free for 2 months. That's a great time to go to the beach, or it's a great time to go out and make your measurements if you want to study something, right? So Anto, that's a great question, because that really is why we do the science that we do. So you're in a great place to be thinking about how we organize this information. And really, if you just stand in the same location over and over and over again, you'll start to see some of those same patterns that we're trying to teach computers to see in our satellite data. So Anto, great questions. And thanks for giving us a great way of wrapping this up, because we've been doing this for a long time, and we're just the generation right now that is working with these tools. And I look forward to seeing what you get to work with in 10 years, because it might be called AI, or it might just be called computers. Who knows?
Thank you.
You're welcome. Thank you, Anto. And thank you, Holly, for hosting all of us.
Oh, yeah, this is great. And just one last thing. Kristen put out in the chat for Anto, for you and anyone else who's interested, a really cool thing that I actually haven't seen yet. So you might want to take a look at that. So there you go. Follow the links that Kristen and Kevin put out for you.
Yeah, I was about to say that Dr. Zakowski added some information about numerical weather prediction, which is exactly what you're asking about here.
Oh, okay. I was going to say that, weather forecasting is based on 5 physics equations, the Navier-Stokes equations. And so then, AI is more of a statistical approach where it's using lots of data, like Peter is saying. So the AI is more refining the weather forecast, whereas the Navier-Stokes equations are determining the waves in the atmosphere from a physics point of view.
Thank you. This is a D question, if you still are here and have time, D. How does AI manage with longitudinal time data?
Yeah, so that is a great question. So there's a lot of reasons that you feel hard about dealing with the longitudinal data, but there are a lot of packages in the machine learning algorithms that we are turning time into model-ready features. So we turn that into features in multi-temporal kind of perspective, and kind of doing that in a we can think that as a repeatable measurement, for example.
And Bruce, you're exactly right. That is one of the most challenging pieces of changing technology. And how, do you want to average every 15 minutes like you can with some of the new satellites, or do you want to average over a decade? That sort of variability also gives you this way of getting over some of the challenges of data collected in weird ways or at different times, and not in a continuous manner like much of our instruments. So you will actually find this challenge in the GLOBE database for sure. And that's one reason why we like instruments, right? Because they might be more consistent. That allows us to minimize this time piece. But Holly, you really hit on UTC. What is this? This whole just aligning ourselves to time is one of the foundational pieces that, the Sputnik satellite sort of gave us the first insights into, right? So time is a fun measurement if you really want to get into that, right?
Thanks for turning my mistake into a positive. Appreciate that.
Glad to do it.
All right. Well, thank you so much. I'm glad to see so much interest in this work. Again, the paper is, we have a link to it on our website. Please feel free to read it. And feel free to reach out if you have any additional questions. We can certainly put you in touch with Peter, Rusty, and Dee directly. So thank you, everybody. Great to see you, and we'll see you next time.